Hello everyone, reporting today for Fun Robotics Network. I'm Abbas, and with me here is none other than Team 12808, RevAmped Robotics from Portland, Oregon. They're coming to you at the Maryland Tech Invitational with a Winning Alliance first pick in Oregon, Inspire Award, absolutely amazing performance at Worlds, just all around awesome team. I can't wait to jump into their intake and deposit, just so fast, so fluid. There's a ton to learn on this Behind the Bot. All right, so Revamped, you guys have done really well season after season. I think it starts from the beginning. What do you think was really important in your strategy that kind of defined how you approach this game?
So when we approach the game, just starting right off at kickoff, we do lots of meetings and we just go through so much brainstorming, especially this season on the intake. So we just do a lot of brainstorming, and then as the league meets play on, we start to see what designs start to work better than others, and we start to see how we can adopt that into our design.
So jumping right into your intake, let's take a look up here. You guys have this like very narrow in profile design now, but from my understanding, you had a different one earlier in the season.
Yes.
What was that like?
So earlier in the season, we had a lot of a wider intake, which had horizontal rollers to reorient it and make it more consistent. But we had issues with that because it just was not, it wasn't specific enough. So we wanted to be a lot more specific because we wanted to, one, get better at specimens, and two, we wanted to incorporate vision into our autonomous, but we did end up going blind as it seemed to be more consistent.
Cool. Yeah, so let's intake a sample and then walk me through the path it takes coming up here. It's just so fast, and I can't wait to see it.
So basically, essentially our A size goes out, our 4-bar goes down to a position where we intake flat, and then they completely retract inside together into the open claw.
Yeah, so taking a closer look at things, if we can turn this off and kind of, if you can pull the intake out. As far as the transfer goes, what was like some of the biggest changes you had to make that super reliable?
So initially we did have some problems with the vertical transfer because gravity is pulling it down as soon as we like try to pull it out, right?
Mm-hmm.
But we did this by having a little latch here. So this is actuated through a spring, and we can open it through opening this trapdoor servo over here.
Okay, so I see it just clips on like to the underside of the top of the sample. Okay, and then when the claw comes to pick it up, is it like, okay, I see, that's very cool. Now, as far as the intake sensing goes, I know you guys have a color sensor. It's super fast. Walk me through how you're using it.
Yeah, so essentially we just have this Rev color sensor here. It'll detect the RGB values of our sample, which we convert to HSV. We detect the color of the sample, and then essentially based on this, we're able to decide whether to automate automatically transfer the sample, or sometimes we'll open the latch and then spit out the sample automatically.
Yeah, and talking about like strategy and using those effectively, I know at the beginning of Autonomous, you guys were telling me how you'll sometimes outtake the intake to clear some space. Walk us through that. What's going on there?
Yeah, so essentially, if we get the wrong color, we will outtake and to avoid getting penalties. If we get our alliance partner's color, typically we play sample most often, and our alliance partner plays specimen. So if we want to feed them, we can outtake and give them the sample.
Okay. Yeah, very cool. And then I also know like teams will have like pusher bars or things like that in the bottom, but I don't see anything like that. How do you guys deal with those samples that are right against the submersible wall?
Yeah, so this was one of the reasons why we decided to go for the 4-bar approach to the intake. So at the beginning, when we go to intake in Autonomous, and when we drive to the submersible, we have the intake in the vertical position. So if you drop it here, that essentially makes the rollers touch almost the floor, and instead of running it in the intake place into the intake direction where we're able to suck up the samples, we run it in the outtake direction. So that creates a pretty big gap in the submersible, so we're able to drop our intake down into that gap and then extend through the submersible to grab more samples.
Fantastic. And last thing I want to touch on with the transfer is the reliability. It seems like your intake is just very secure, always in the right place. And walk me through how you do that. I think you have just a very clever mechanism that teams should really learn from year after year.
Yeah, so in order to ensure consistency with our transfer, we utilize a voltage sensor inside of our intake main arm. So to trigger our transfer, we always have to, we have the conditions that our horizontal slides and vertical slides both have to be completely retracted. So that means everything is going to be in the same place in relation to themselves. And we also have the arm voltage to tell that the arm is completely up.
Yeah, and as far as like back driving the intake or anything like that, I know this like you can't pull your intake back out.
Yes.
So what's going on there?
So here we have a latch. So we have an Axon Micro that actuates this slide lock. So it locks on just this screw right here on the horizontal slides. And when we bring the horizontal slides in, it completely locks in. So that means that we do not need to drive our horizontal slides when we're not using them, which helps us save power.
Awesome. Now jumping into your lift and your outtake and everything, slides are super, super fast. What do you think are the key factors there?
So I would say that the key factor definitely has to be from our counter spring. So we're running dual counter spring. So we have two separate methods. So the biggest part of it is this, this is inspired by RoboKing's center stage arm, where we pull this arm down with a bunch of bungee cords. So before this was rubber bands, but we use bungee cords as we found they snap a lot less. And it pulls the steel cable. So usually, if you're using this arm, you would have to rig these slides in cascade, but we rig our slides continuously, and we're able to do this by having this dual spool system. So we this arm pulls on this steel cable, which rotates a tiny spool on the bottom, and with a large gear ratio, this spins this flywheel super quickly. So it's a lot lesser torque and less mechanical advantage, but it spreads out the force of this arm coming down throughout the entire lift.
Yeah, and then I also see the bungee on the front. So
Yes.
I think that's becoming more and more popular. What advice do you have for teams to make sure their bungee is like really consistent and just doesn't get loose over time or anything like that that you guys have to deal with?
So when it comes to bungee, the one main thing to at least optimize this is to make a bungee lengthener, or be able to lengthen your bungee, because that would reduce the amount of tension lost as the slides come up. So he'll demonstrate this here, but we have this, if you see here, we have this bungee lengthener here, which is just a bunch of idlers which the bungee routes through, so that decreases the amount of tension loss while we raise the slides.
Fantastic. And now going on to your outtake, you have a ton of degrees of freedom. I think one thing that really stuck out to me is that you actually simplified it a bit between
Yes.
WTI and MTI or WCI. Why? And what did that do for you?
So when we simplified the depot, the main reason for this was just consistency. So it was quite inconsistent with the transfer, as we had horizontal slides which would make the claw have to be closed when it comes down and then open once again just to transfer. So in order to fix this, we gave our depot a lot more clearance. So it's a lot more open than when we had the horizontal slides. So we have all this space for both the turret to move and the claw to be open, so our transfer is much more consistent. And on top of this, we decided to be much more sample based. So we decided to get rid of these slides as well, just to decrease the weight of our deposition.
Awesome. Yeah, and talking about stacking, I mean, you guys are putting like 25, 26, 27 samples in the high basket, which is very much on the higher end of what teams are doing. How? What's the strategy there?
Yeah, so we found out near the beginning of the season that being able to stack a lot of samples in the high basket is really essential, because of course the high basket is worth double as much as low basket. So we try and stack the most amount by being able to have multiple modes. So we have this first mode, which drops with the deposition up, which means that we can go a lot faster since the slides don't have to move as much. But we do also have, if I restart the program, if we have a another mode which utilizes this wrist here to stack blocks in a grid-like pattern, so we're able to stack the most amount of samples possible.
Yeah, we see that
yeah.
coming down.
And with this, we use our pinpoint sensor to track our robot's heading, and our wrist is able to compensate for this. So it's always aligned to the
Yeah,
basket.
that's fantastic. Now, last couple things I want to talk to you about is first intaking strategy. We see a lot of teams that prefer to be completely perpendicular to that submersible wall. They have to be like very flat in the intake. You guys just take like a very direct angle and just go in and out. At what point in the season did you realize that that was the play?
So we knew that driving the least as possible would be the fastest way to get, of course, from to basket back to intaking. So we normally would go at an angle, as then you just don't have to turn at all. And utilizing our turret as well, we don't need to turn. So we do that mainly when there are no other robots around, and we do intake perpendicular when we have another robot near the submersible, as we just try and be as fast as possible.
Awesome. Yeah, it makes a ton of sense. Now, last couple topics are software related. I see you guys have some ultrasonic sensors up here or something. What's going on with these? How do you use them?
Yeah, so these ultrasonics allow us to make fail-safes on our autonomous. When we drive up to the submersible, we were finding that sometimes it hits the submersible too hard, and using these ultrasonics, we're able to stop ourselves and relocalize our position.
Yeah.
And then,
as far as like refresh rate and stuff goes, I know that can be an issue for other teams. How did you deal with that? If not, like, why wasn't it an issue for you guys?
so our ultrasonic sensors were all right, I think, because first of all, they're plugged into analog input, which means they don't affect our loop times as much as an I2C device would. And secondly, I think we know when our robot's entering based on our pinpoint odometry, and we're able to tell the sensors when to read.
Okay, so you're only reading the values when you're near the submersible. Okay, that's cool. And as far as pathing goes, you know, you guys are very versatile in where you're picking up, and you're always dropping off at the same place. What's going on there?
Yeah, so this season we're actually using pedropathing. Last season we used Roadrunner, which was very consistent, but it didn't allow us to score as many points as possible. And this season we co-developed pedropathing to be as fast as possible. It allows us to correct our robot in order to be more consistent. So if our robot gets knocked off path, it allows us to go back, and it has very fast deceleration.
Awesome. Yeah. Revamp, thank you guys so much. Your intaking and practice has been so fantastic to watch. You have, I guess, 5 more matches at MTI. Can't wait to see how they go. Good luck for the rest of the competition. Reporting for Fun Robotics Network, I'm Abhas, and this is Team 12808, Revamped Robotics. Thank you.